These are for you. You got it.
But did you remember the things?
Yeah,
They studied that.
Yeah, this is right.
A little episode ringing, but yeah.
What does that mean?
All right, let's get going.
And you never know. Yeah.
How are we doing today? Pretty well. What a beautiful, this is a beautiful morning. Other than the frost. Frost. What'd you say? See, I'm like scraping the car windows. What do you do?
The whole math class. Do you have a garage?
Yeah.
Most of this.
See, Tessa, we have it on the other time of year. It's, we have a camper, and so my wife is like, we don't want mice in our camper. Let's park the camper in the garage, and then she parks her car in another part of the garage. So I park outside. It's a pop-up, like a.
Oh. That's a good
Looks like that.
So the plan is I have a workshop, the 2-car garage workshop. All right, I got my tools on most of this site. So I put my garage door opener. I had bought it like 2 years ago. I'm gonna play it because I've been too lazy. Not really, I'm busy. If I can get that in, then I'll have that garage to park in. I know you guys care, so I just want to share with you. Then, no more scraping windows. See, the camper is a lot harder to move around. So, like, if I need to work in the workshop, I don't want to, like, pull the camper out. So I'd rather leave it in the attached garage. And then pull my car in. Like, I can move my car out and move tools around. I think we should brainstorm this whole class period about how you guys can help me. Actually, this lesson is pretty short and pretty easy. Good news. You guys are going to have time in class to work on homework is my goal. This lesson, if you were to look in the book, the lesson is a lot longer than what the notes show. There's some topics in this section that are really weird and random. All right? And like, when would that ever come up? And so we're not going to cover those topics. We're just going to cover the main ideas in the section that will help us into the idea of congruence. All right? So where are we heading? Well, we're going to be doing dilations in the next section. Do you know what a dilation is? Have you heard that word? Yeah. Like you probably heard your pupils dilate, like the pupils grow and shrink, right? Dilations are a shrink or a grow by a factor, all right? And so we'll talk about how shapes can shrink or grow depending on the scale factor. Then we're going to move into the idea of congruence. And that's going to be a big idea for the year because we're going to be able to show if triangles are congruent to one another, all right? And we'll have some theorems that tell us about that. So we have to understand the idea of congruence. We've been working on the idea of rigid motions and how of the ones we've learned so far, reflections, rotations, translations, I think we could all agree those are all rigid motions. If you do a rigid motion, you haven't changed the size of the shape at all. You changed its location, but not the shape or the size. Agree? So dilations, I think you can see, is going to change the shape or size. We'll find out about that tomorrow. But for today, just a general idea, conversation about congruence. All right, so we'll have some guided notes here. In your guided notes, we got some fill-ins. I tried to highlight some of them for you. You understand this idea. I mean, we really don't need to discuss it too much, but let's formalize it with some notes. Two figures are congruent if and only if there's a rigid motion or a composition of rigid motions that maps one of the figures to the other. So we're copying down these guided notes. There you go.
Yes.
You clean out your backpack right now.
No, that took
You're cleaning out your laptop. Like deleting files, right?
No.
Is your laptop like my garage?
Yes.
Okay.
Yes.
I hate scraping windows like that. I'd rather turn the car on and just turn like the defroster on for like 5 minutes than scrape car windows.
Why don't you do that?
I didn't have time. I should have. I didn't realize it was gonna frost.
I would have just stayed home.
I know. Is that what happened yesterday, Olivia?
Yeah.
Car windows were frosty,
Yeah.
but I just can't take it. And as we know, in green there, congruent figures have the same size and shape. So the main idea for today in the examples is going to be identifying the rigid motions that gets us from the one figure to the next. So you know how we've been using the words pre-image and image. Today's goal, it's kind of like what we've been doing, but instead of us transforming it, it's going to be done for us, and we're just going to say, okay, oh, it looks like it's been reflected and then translated, or it looks like it's been rotated. And we'll have to map one figure onto another by identifying the rigid motion or composition that gets us there. And what are our options again? What three transformations do we know? Reflections, rotations, translation. Oh, they were even there for us. Look at that. Translations, reflections, rotations. We good?
No.
Sounds like we're good. You're being slow, Olivia. All right. Identify any congruent figures in the coordinate plane. All right, let's go through some of these together. We've got, let's start up top left. We've got triangle HIJ. Triangle HIJ. Take a look at your picture. Triangle HIJ. Is it congruent to another triangle in this picture?
Yes.
Which one?
UST.
UST. Triangle U. Now I'm gonna say UTS, and I don't know that for sure, but here's what I'm gonna say to you. It's good to get in the habit of trying to name these in the correct order. Now, can you guys listen for a second? This is hard to explain. When I say name them in the correct order, it's like saying if we have a triangle that looks like this, and it's called A, B, C, and then the same triangle but it's named D, E, F. To get in the habit, because we're going to be doing this so much when we deal with congruent triangles, to get in the habit, let's start practicing now, of naming them in corresponding order. What I mean by that is if I go from B to A to C, I've gone across the short side to the right angle and then across the long side, right? BAC. Triangle BAC. Now, where would I start here? D, then E, then F. Do you agree? But let's go back to the problem we're working on. For the ones we started with, bless you, for the ones we started with, The only one we know that pairs up, what letters in those two triangles pair up together? Yeah, I and T. Do you agree? I and T. So I don't know what order to put, but I'm going to put the I and the T together. The other two sides, bless you. The other two sides are the same, right? So those order in this triangle, these triangles did not matter. But the I and the T have to match up. Let's get in the habit of doing that. Does that make sense? Does that kind of make sense or no? Awesome. All right. Next. Let's go to this next triangle here. By the way, did we miss any? Nope, those are congruent. All right, next one. Actually, let's finish off the red ones. I kind of skipped over it. What can you see any rigid motion that would get us from one of the red triangles to the other one? Tyler?
Rotation.
How many degrees? Yeah.
180.
I agree. Do you guys agree with that? Tick, 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 tick. 180? Get out of there. I agree. 180 degree counterclockwise rotation will get us there. Awesome. Next one. Triangle GEF is congruent to triangle, well, let's be careful. I went from G to E. That went across the longer side of 3 units to E and then across the side of 2 units. So let's go in the same order. Which one does that match up with? Who can raise their hand and tell me? Mackenzie. M, K, L. Perfect. Triangle M, K, L. And she even nailed the order. And what, do you want to continue with it? What rigid motion would get us from one of them to the other?
A reflection.
Yep, specifically. Perfect, thank you. X-axis reflection. Got it. So we did those two. Next. I think we can agree those are congruent. So now squares and rectangles don't have specific shapes in front of them. We just write A, B, C, D is congruent to, I don't know what order. It doesn't really matter what order for that to name the letters, right? We don't know. So let's just say Q, P, R, N. Do you guys see a rigid motion to get us from one, or a composition rigid motions page?
Translation.
Translation, good. And we probably say if we picked one of these, doesn't matter what point you pick, down 1, 2, 3, 4, 5, 6, left 1, 2, down 6, left 2, would be the translation that gets us there. And I don't see any figure congruent to X, Y, W. Pretty easy, right? You guys good with that? Now, another name for a rigid motion or a combination of rigid motions is a congruence transformation, because you keep the figure congruent from start to finish. So was there a blank to fill in on that one?
Yeah.
Congruence transformation. Now, there is a special symbol for a parallelogram. It's actually just a parallelogram drawn in front of it. So now we're told there is a congruence transformation to map this onto the other one. Now, all eyes up here for 1 second. The order matters. That's why I emphasized in the triangles to name them in the corresponding order. What does that mean? A gets mapped onto E. B gets mapped onto F. C gets mapped onto G. And D gets mapped onto H. The order matters. That helps you with identifying the pre-image and the image. So A started here, and it turns into E. So it ends up here. Take a minute, talk to your table partner, see if you can describe a congruence transformation that maps ABCD to EFGH. Ready, set, go.
So
Pretty sure this is like the
well, what else I do is just rotate it 180 and say that C goes to E, E goes to like Y.
It doesn't go vertically too.
That's what you have to decide.
Look, it has to get from here to here. Reflecting it over the x-axis is only going to get it up here. You have to then flip it again
No,
over
I
the
was
y-axis.
making this one reflect over to here, and then bending it down to the
Reflection of the water.
We could accomplish the same thing by reflecting it over
What
the
if you
y
rotate
equals
it at 180? Well, I mean, you can't do that because like the way things already said.
Why would you reflect it twice?
reflect it once.
What do you do backwards?
That's why you
But
But yeah, I see.
All right. You guys need more time, or are you ready?
No, because if you reflected it that way, it'd be like this. It'd be sideways. See? Yeah. It'd be like this.
That's what it's supposed to look like. I'm sure you guys have this.
I mirrored it over.
Preston, what do you think?
We said that we should do translation y minus 4, so then it goes down 4.
So down 1, 2, 3, 4.
And we have to do a reflection over the y-axis.
And then 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then reflect it over the y-axis. And so we kind of double check: is B prime, or what was B, needs to get mapped onto F? Yep. And if you had something different, don't erase. I'm seeing several of them here. Okay. So a translation down 4 and then a reflection over the y-axis. I'm good with that. Who has another one? Olivia?
We reflected first and then went down 4.
So a reflection over the y-axis first. And then down 4, you said?
Yeah.
I'm seeing that too. Anthony?
Could you do 2 reflections and go over the y and then the x?
Here's what would happen if you went over the y. 1, 2, 1, 2. And then that's over the y, correct?
Yeah.
And then over the x, watch what happens. A double prime would be here. Do you agree? And C double prime and D double prime would be down here. Can you see that, how that wouldn't match it up? I saw one more. Do you see another one? I heard some people saying rotate it 180. What would happen if you did that? Remember, it's like a watch hand, right? So we got like here, tick, 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 tick. Wouldn't A prime be there? But we want A to map onto E, correct? Yeah. Could you make it work? How? Would that work? Let's see. Where would B end up if we rotated 180? 3, 1 turns into -3, -1. And so that would be B prime. And it needs to map onto F, correct? So yeah, A prime and B prime after that 180 rotation, then you could translate it down a couple of units to get there. These are just a nightmare to grade because I'd have to, it's like trying to see everybody's different train of thought. And, oh yeah, I need to work it out and see if that works out too. And so, but these are all right, and these are all good transformations that gets us there. You guys okay with being able to do one of those? Okay. That's it, right?
Yeah.
Awesome. Just have some time to work on homework. What? Is that too much class time? I apologize. You guys want me to talk more?
I wasn't expecting you guys to do that fast this time.
Here, let me show you what
Ready?
he reflected.
You're supposed to be ready yesterday. Ready yesterday. Where were you yesterday? We missed you.
I'll do it later. I just gotta.
You can't show this
Jackson, we're worried about you.
because it's backwards. Like it's in the right place. So it'd be here. Maybe
Say it.
do that.